Hello everyone, welcome back to Paideia classes. In the last video, we have learned what subsets are, and today we will solve some example to really get the hang of it. So let's revise the last lecture. So what is a subset? A set A is said to be a subset of a set B if every element of A is also an element of set B. Or mathematically, A is a subset of B. A is a subset of B. If whenever A belongs to A, then A will also be in B. Or we can also write it simply, A is a subset of B. If A belongs to A, implies A belongs to B. There are 2 points that every set is a subset of itself. And empty set is subset of every set. So we have discussed till now. Let's see some examples. Let's see the relation between the sub Q, set of rational numbers, and set R, set of real numbers. Now, what are rational numbers? So, rational numbers are numbers that we can write in the form of P by Q, where P and Q are integers and Q is not equal to 0. This is the set of rational numbers. And all the elements that we cannot write in the form of P by Q, where P and Q are integers and Q is not equal to 0, are called irrational. Okay? So, we denote it by set T. Okay? And the numbers together, rational and irrational numbers together, makes the set of real numbers. Okay, so set of real numbers is nothing but rational numbers and irrational numbers. Both together form the set of rational. So it means if an element X, suppose an element X belongs to Q, okay, that is X is a rational number. So it means that this will also be a real number. Why? Because real number is nothing but the set of all rational and irrational numbers. Or we can also say that X belongs to. So we start with X belongs to Q and we get X belongs to R, and X was an arbitrary element. So it means every element of the set Q is also the element of set R, or we can say that every rational number is also a real number, and therefore Q is a subset of R. Now let's see the next example. The next example is if A is, what is A? A is the set of all divisor of 56. And B is the set of all prime divisor of 56. A is the set of all divisors of 56. We don't even need to calculate. A is the set of all divisors of 56. Suppose this, and this are the divisor of 56. Now, B is the set of all prime divisor of 56. It means you will choose your all the divisors of 6 are here. So you will choose those dividers. You will choose those divisors of 56 which are prime to get the set B. This means that you are choosing your elements of set B from your element of set A. This means that B is the smaller set and B is subset of A, because if any element X belongs to B, so this means that X is a prime divisor of 56. So this will mean that X is a divisor of 56, and which will implies that X belongs to A, and therefore B is a subset of A. So since we are taking X as an arbitrary element, it is true for every element of set B. Now if A, suppose we have a set A as 1, 3, 5 and B as X, such that X is an odd natural number less than 6. Then we will see the relation between A and B. All the odd natural numbers less than 6, what would be? The natural numbers means 1, 2, 3, 4, 5, 6, 7, and so on. Now less than 6 means you cannot go beyond 6, right? In fact, we cannot go beyond 5. Now we need to collect the odd natural numbers that are less than 6, and that would be 1, 3, 5. If we look carefully, all the elements of set A, all the elements of set A are also the element of set B, and vice versa. So A is a subset of B and B is a subset of A, which implies that A is equal to B. Now, let's see one more example. Let A is equal to A, E, I, O, U, and B is equal to A, B, C, D. Now, it is clear that E belongs to A, but E does not belong to B, which means that A is not a subset of B. So since all the elements of A should be the element of B, then only we can say that A is a subset of B. So even if you find one element that does not satisfy the condition, A will not be a subset of B. And also, B belongs to set A, B belongs to set B, but B does not belong to set A. So this implies that B is not a subset of A. B is not a subset of set A. So in this example, neither A is a subset of B nor B is a subset of A. Now, suppose we have two sets A and B. If A is a subset of B and A is not equal to B, then A is called proper subset of set B. What does this mean? They are saying that if every element of your set A, this is your set A, is also the element of set B, but A is not equal to B. So how will that be possible if there is more element to set B? Then your A will be a proper set of B. And A is called proper subset of B, and B is called superset of set A. For example, if A is equal to 1, 2, 3, 4 and B is equal to, suppose A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4 and 5. Then we can see that each element of set A is also an element of set B, but A is not equal to B because there is more element. So this means that A is proper subset of set B and B is the superset of set A. That's it for today's video. In this video, we have worked through some examples of subset to solidify our understanding. We also explored different types of subsets, including those within the set of real numbers. So we mainly discussed that and some other examples. And I hope these examples help make things clearer. Keep on practicing to master the concept. And if you found this video helpful, please give it a thumbs up, share it with your friend, and don't forget to subscribe to the channel. If you have any question, feel free to drop them in the comment section below. And I'll see you in the next video. Thank you for watching.